Hello and welcome to Lesson 4, Radio Frequency Measurements Taken on the Bench. So in this lesson we're going to look at the typical use of bench measurements and actually show you a real life example that I did. Bench measurements, yes, literally measurements that you take on the bench. There is nothing fancy about the naming there. The kind of thing that you can test here is a sealed unit or something that allows a low power signal to be transmitted. So if you're an RF engineer, you will spend a large portion of your time sat at one of these. It's a vector network analyzer with an integral desk, a really common sight. You have your very stable, proper CAL cables, the big, thick black cables, and they are very thick, significantly thicker than the small SMA coaxial cables that you can get. They're very stable, and they're what you need to use for high quality test measurements where the cable might be moving around. And you can see here the cable comes out of one port in the vector network analyzer, goes into the sealed unit, and then into the network analyzer itself. So the measurement that I was taking was actually a free space measurement because it was very low power that we were transmitting. So we just surrounded everything in RAM. So you can see the flat RAM behind it. So this isn't the spiky RAM, this is flat RAM behind it. It was all the way around the sides and it had a lid as well with our little test unit. So we were testing a reflector. So this is basically a set of grid lines. And depending on the polarization of the radiation that comes in, it would either reflect polarization. If you turn it around the other way, it would transmit the polarization. So we were taking S21 and S12 measurements. So we were looking at the transmission both ways from both of the horns. So you had two horns, one connected to the first port of the network analyzer, one connected to the second, and we would transmit from one, receive on the other port, and vice versa, transmit through one and receive on the other one. And we looked at the performance. We took those S parameter measurements of the performance of the reflector in different orientations. So we had a grid, circular grid, so we had different orientations. We were worried about in steps of 90 degrees, so we had 4 measurements for our results. And these are taken as a function of frequency across J band, so this is 12 to 18 gig. So here you can see in transmission there's very little absorbed by the reflector, as it should be, because it should pass straight through. You can see you've lost maybe a dB or 2 as you go along, which is not very much signal loss, because you have got obviously losses through all the cable, losses through the horns, losses in free space, so that's not just all through the reflector itself. However, you rotate 90 degrees, you should get a reflection, so you should get virtually no signal. So we're way down at minus 26, 27 dB, which is a brilliant result. It shows our reflector works really well. So conclusions for this chapter. Bench measurements are used for sealed units or where you can do a low power transmission. You need to set them up with the user in mind. Make sure you protect the user at all points. And you've got to be careful that there's no external signals interfering with your results. Okay, so we're going to move on next to looking at free space RF measurements.